I'm Gwen Stephanie D, and today we're diving into some exciting algebra problems. We'll explore each question step by step, uncover the concepts behind the numbers, and of course solving together. Let's get started. A study showed that the number of mice in an old abandoned house was approximated by the function defined by m of t equals 6 times the logarithm base 4 of the quantity 2t plus 4, where t is measured in months and t equals 0 corresponds to January 1998. Find the number of mice in the house in A. January 1998, B. July 1998, and C. July 2000. Question number 1 tackles a problem that models the number of mice in an old abandoned house over time. The number of mice, m of t, is approximated by this function. M of t equals 6 times the logarithm base 4 of the quantity 2t plus 4, where m of t represents the number of mice in the house and t represents the number of months since January 1998. Specifically, we were asked to find the number of mice in the house during 3 different months: January 1998, July 1998, and July 2000. First, let's understand how to determine t for each given month. The value of t represents the number of months since January 1998. For January 1998, t is equal to 0, since it is the starting point. For July 1998, which is 6 months after January 1998, t is equal to 6. For July 2000, which is 30 months after January 1998, t is equal to 30. Now, we can substitute these values of t into the given function to calculate the number of mice for each specific month. First, let us calculate the number of mice for January 1998, where t is equal to 0. Here, we're going to substitute t is equal to 0 into the function m of t equals 6 times the logarithm base 4 of the quantity 2t plus 4. So we have here m of 0 is equal to 6 times the logarithm base 4 of the quantity 2t, in which t will be replaced with 0 plus 4. So we're going to simplify it. We have m0 equals 6 times the logarithm base 4 times 2 times 0, which is 0, plus 4 is equal to 4. Now, we know that the logarithm base 4 times 4 is equal to 1, because 4 to the power of 1 is equal to 4. So we have here m of 0 is equal to 6 times 1, which is also 6. So this means that the number of mice in the house in January 1998 was 6. First, let us calculate the number of mice for January 1998, where t is equal to 0. Here, we're going to substitute t is equal to 0 into the function m of t equals 6 times the logarithm base 4 of the quantity 2t plus 4. So we have here m of 0 is equal to 6 times the logarithm base 4 of the quantity 2t, in which t will be replaced with 0 plus 4. So we're going to simplify it. We have m0 equals 6 times the logarithm base 4 times 2 times 0, which is 0 plus 4, is equal to 4. Now, we know that the logarithm base 4 times 4 is equal to 1, because 4 to the power of 1 is equal to 4. So we have here m of 0 is equal to 6 times 1, which is also 6. So this means that the number of mice in the house in January 1998 was 6. Now, let us proceed to July 1998, where t is equal to 6. It is the same process that as substitute t is equal to 6 into the function m of t equals 6 times the logarithm base 4 of the quantity 2t plus 4. So we have here m of 6 equals 6 times the logarithm base 4 of the quantity 2t, which t will be replaced with 6 plus 4. Let's simplify the equation. We have here m of 6 equal to 6 times the logarithm base 4 times 2 times 6, which is 12, plus 4 is 16. So we know that the logarithm base 4 times 16 is equal to 2, because 4 to the power of 2 is equal to 16. So we have here m of 6 equals 6 times 2, wherein 6 times 2 is equal to 12. Therefore, the number of mice in the house in July 1998 was 12. And finally, let us proceed to the last month, July 2000, where t is equal to 30. Again, substitute t is equal to 30 into the same function. So we have here m of 30 equals 6 times the logarithm base 4 of the quantity 2t, which again t will be replaced with 30 plus 4. I'm going to make that clear. So now, let us simplify it. We have m 30 equals to 6 times the logarithm base 4. So this 2 times 30 is equal to 60 plus 4, which is 64. We know that the logarithm base 4 times 64 is equal to 3, because 4 to the power of 3 is equal to 64. So we have here m 30 plus 6 times 3, which is also m to the power of 30 equals to 18. Thus, the number of mice in the house in July 2000 was 18. So in summary, in January 1998, when t is equal to 0, there were 6 mice. In July 1998, when t is equal to 6, the number of mice grew to 12 mice. In July 2000, when t is equal to 30, the mouse population reached 18 mice. This illustrates how the mouse population increases over time, according to the logarithmic model given by the function. As we can see, the number of mice grows over time, but the growth rate shows as time passes, which is characteristic of logarithmic growth. Assuming you want to minimize the amount of work required, tell whether you would use the substitution or elimination method to solve the system. Explain your answer, then solve the system 6x minus y equals to 5 and y equals 11x. For question number 2, should we use substitution or elimination? Let's analyze. We have this system of equation. We have 6x minus y, which is equals to 5, and y equals 11x. Since the second equation, which is y equals to 11 of x, already expresses y in terms of x, substitution is ideal. It allows us to substitute y directly into the first equation, which is 6x minus y equals to 5, without additional manipulation. That makes sense, right? Now, let's get into the process. First, substitute y equals 11x into the first equation, 6x minus y equals 5. In result, we have 6x minus y that will be substituted with 11x equals 5. 6x minus 11x is negative 5x equals 5. Let's divide it by negative 5 for us to be left with only x. So we have here 5 divided by negative 5 is negative 1. That means that our x is negative 1. Now, let us substitute x equals negative 1 back into y equals 11x in order to find out the y. So we have here y equals 11x. Substitute x in 11x with negative 1. So we have here y equals negative 11 times negative 1 over here negative 11. Solve the system of equation. 2/3 x minus 1/4 y plus 5/8 z equals 0. 1/5 x plus 2/3 y minus 1/4 z equals negative 7. And negative 3/5 x plus 4/3 y minus 7/8 z equals negative 5. Let's eliminate fractions for simplicity. Multiply through each equation by the least common denominator of the coefficients to eliminate fractions. For the first equation, 2/3 x minus 1/4 y plus 5/8 z equals 0, the LCD is 24. That means that all the denominator of these fractions, are divisible by 24. So with this, we're going to multiply this equation by 24. So 24 divided by 3 is equal to 8 times 1 times 2, which is 16x. So we have here, let's label it as our equation A. We have here 24 divided by 3, 8 times 2 was 16x. 24 divided by 4, which is 6 times negative 1. So we have here negative 6y. Then 24 divided by 8, which is 3. Multiply 5z, we have here 15z equals 0 times 24, which is still 0. So our new equation for the first equation, the simplified version of the first equation, is 16x minus 6y plus 15z equals 0. For the next one, we will label it as our equation B, 1/5 x plus 2/3 y minus 1/4 z has the least common denominator of 60. So 60 divided by 5 is 12 times 1. We have here 12x. 60 divided by 3 is 20 times 2. Here 40y. And 60 divided by 4, which is 15 times negative 1, would be negative 15z. Equals to negative 7 times 60 is negative 420. So that means that this is the simplified version of the equation 2. Now let's label the third equation, the simplified version of the third equation, as C. So we have here as our common denominator, which is 120. So 120 divided by 5, which is 24, times negative 3, which is negative 72, times x, plus 120 divided by 3, which is 40, times 4 is 160, times y. 160y. And 120 divided by 8, which is 15 times negative 7 is negative 105z. And 120 times negative 5 is negative 600. So we have here the more simplified equations that will be used for the further solution of this problem. Now, we are left with this two variable system, the equation D and equation E. First, let's eliminate x. Multiply the equations to align the coefficients of x. So let's multiply equation D by 10 and equation 5 with 7. So in result, we have 14x plus 70y equals negative 210 times 10. Should be going to 150x plus 170y equals negative 2100. And for the equation E, we have 140x plus 13y equals negative 2100. So we could subtract this equation through elimination. So as we can see, we could eliminate 140x from both of the equations. So we are left with 170y minus 413y, which should be going to be 243y. Negative 243y equals to 0. So let's eliminate the negative 243 from the y. So we are left with y, which is equal to 0. Now, let us solve for x and z. Let's substitute y into the equation D. So I have here 14x plus 17 y, which is substituted by 0, equals to negative 210. So we will simplify it. It's going to be 14x equals to negative 210 divided by 14. So we have here x is equal to negative 15. Now we have found out the y, which is equal to 0, and x, which is equal to negative 15. Now let's solve for z, now that we have the value of x and y. So let us use the equation 1, the original equations. Now that we have solved the values of x and y, wherein x is equal to negative 15 and y is equal to 0, let us solve for z. We may use the original equations a, b, or c in order to solve for z. This time we will use the equation a. So we have here 16x minus 6y plus 15z is equal to 0. Let us substitute the values of x and y in this equation in order for us to find out the values of z. So we have 16x, which will be replaced with negative 15, 6y, where y is replaced with 0, plus 15z equals to 0. So let's simplify it. We have 16 times negative 15 is negative 240. Negative 6 times 0 is 0. So plus 15z equals to 0. Let's arrange it. We have 15z equals to 240 divided by 15. So z is equal to 16. So our solution for this system of equations are x is equal to negative 15, y equal to 0, and z is equal to 16. Now, let's verify the solution x equals negative 15, y is equal to 0 and z equals to 16 by substituting them back into the original equations. So these are our original equations. So let's proceed with equation number 1. So 2/3 times x, which is negative 15, minus 1/4 times the value of 0 plus 5/8 times 16, that is equal to 0. So 2/3 of negative 15, or 2/3 times negative 15 is negative 10. 1/4 times 0 is obviously 0. Plus 5/8 times 16, which is 10, positive 10. So negative 10 minus 0 is negative 10, plus 10 is 0. So that means that our solutions are verified for equation 1. Let's proceed with the second equation. 1/5 x. So for 1/5 x, we're going to substitute x with negative 15. That for 2/3, 0. And for 1/4, 16. Plus negative 7. 1/5 of negative 15 is negative 3. 2/3 of 0 is obviously 0. And 1/4 of 16 is negative 4. It's negative 7. So negative 3 plus 0 is negative 3 minus 4 is negative 7. That means that our solutions are also verified for the second equation. Now, let us proceed with the third equation. We have here 3/5 x, where x is negative 15, plus 4/3 y, where y is 0, and negative minus 7/8 z, where z is 16, plus 2, negative 5. I'll adjust that for you. So in this case, negative 3/5 of negative 15 is 9, plus 4/3 of 0 is 0, and negative 7/8 of 16 is negative 14. So let's solve it. 9 plus 0 is 9, minus 14 is negative 5, which is also equal to negative 5. That means that solutions x equals to negative 15, y is equal to 0, and z plus 16 satisfies all three original equations. Thus, the solution is verified as correct. And that's a wrap for today. I hope you find these problems as exciting as I did, and most importantly, that you learned something new along the way. Keep practicing and stay curious. Goodbye, everyone.